Hello and welcome to the Monica Motion Dark Science Investigation. This is Karma from Karma Logic Studios, hosting today's video. Recently, the NASA Stereo Ahead satellite captured several massive coronal ejections. One such event in particular occurred July 20th. Earth is due to pass through the plasma wave July 23rd through late July 25th. We begin on the 17th of July because of the spectacular flare emanating at the bottom left side of the solar disk. Incidentally, the solar analysis is about 3 minutes long. I mention this because we have already covered the last 5 minutes in previously videos. For those seeking a deeper understanding of solar max, don't miss the last 5 minutes. During the solar maximum, highly energetic sunspots migrate far from the equator, just before the north and south poles exchange their orientation. This simulation illustrates how stable-looking electromagnetic field lines become tangled and chaotic when approaching the solar max. Note that the field lines, next to red arrows, are bursting out the surface of the sun as the solar max approaches. If the electromagnetic tangles becomes too unstable, it will explode plasma out into space. These mass ejections can be somewhat weak or, as with X-class flares, outrageously strong. And finally, they are indiscriminate about their trajectories. Coronal mass ejections, or CMEs, may hit planets, like Earth, or miss them altogether. When solar events are minor, we can all enjoy the colorful light displays. However, there is more to this story than augmented sunspot activity and colorful lights. Just as an electromagnetic field protects Earth from deadly radiation coming from the sun protects the entire solar system from the extremely high-velocity ions it encounters from supernova events. NASA has predicted that the poles will flip soon. This graph illustrates how far the sun has strayed from the predicted path in this cycle. Starting at the 2020 solar minimum, it quickly became clear, note yellow line next to the red prediction line, that sunspots were propagating faster than they were expected to. The new prediction represents both an increase in the number of currently observed sunspots, as well as an overall increase in the total number of sunspots manifesting themselves at the solar maximum. Stanford's Wilcox Solar Observatory is one of few observatories in the world that monitor the sun's polar magnetic fields. They have been tracking the sun's polar magnetism since 1976. During this time frame, they observed 4 polar flips. Note that there is a brief amount of time when the sun has no magnetic field whatsoever. The sun's domain of magnetic influence extends billions of miles beyond Pluto and is known as the heliosphere. The sun's slowly rotating magnetic field induces about 1/10 billionth of an amp per square meter, 10,000 kilometers thick and billions of kilometers wide. During field reversals, the current becomes very wavy. As Earth orbits the sun, it dips in and out of the current. When Earth is outside the current, we are no longer protected from cosmic rays, accelerated to nearly light speed, emerging from supernova and other energetic events in the galaxy. Astrophysicists suspect that cosmic rays striking Earth may cause climatic changes, like cloud cover. Obviously, this would be bad on many levels, adversely affecting our ecosystem and the biological life forms who depend on it. Not to mention the possibility of damaging orbiting satellites, probes, and those brave souls who venture out and into space. At the moment, the poles are oddly out of sync as the North Pole is already shifting while the South Pole races to catch up. A sure sign, say the scientists, that the poles are about to flip soon, probably in the next 3 to 4 months. We will keep you updated as the sun follows along its unpredictable path. Until then, this is Karma saying thanks for tuning in to the Monica Motion Dark Science Investigation. And remember, Karma logic suggests that every bit of light you see must first navigate the darkness. Bye now.